As you can see, today's lesson is called 7.3 Compound Events. Raise your hand if you think you know what that word compound means. What do you think?
2 things, but yeah.
Okay, 2 things. Basically, something that's more than one, in this case, more than one event. First thing I want you to do is write down this vocab word, sample space. Here you can see a sample space says the set of all possible outcomes of one or more events. So basically, this creates a space for us to show what the different outcomes of an event are going to be. All right, so we're going to find the sample space using a tree diagram. You randomly choose a bread and a type of sandwich. Find the sample space and how many different sandwiches are possible. So who has a favorite sub shop that you enjoy going to? What do you like?
It's a place called Sam's, but it's up in Maine.
Okay, it's in Maine, but it's called Sam's. Angie's. Firehouse Subs. Also the same. Subway. Publix, I like theirs too. All right, so there's a lot of sub places out there. Normally, the first thing they say to you when you come in is, what do you want? Bread. So we are trying to come up with the different outcomes that we could have here at this sub shop. So I want you to write over here on the left-hand side, bread. You want to write kind of small. There is a space that we have here in our sample space, but it's not too big. So there's 2 kinds of bread. What were the 2 kinds of bread they have at this shop? Wheat and sourdough. Raise your hand if you've ever had sourdough before. How many of you like it?
I ate it yesterday.
How many of you do not like it?
I don't really.
Wow. Sourdough is not my favorite.
I love sourdough.
Okay. After that, there are different types of sandwiches we can get. How many different types of meat do they have? 4 different types. Here's what I want you to write next. Write type, off to the right. And there are, as you said, 4 different types. They could have ham, turkey, steak, or chicken. So the first kind of outcome, you can see each of those have that you could get it with bread. Off to the right now, we're going to come up with the different kinds of outcomes we can get. I'm not going to write out the whole thing, but just put wheat with ham. The next one, we can see wheat with turkey. Then we've got wheat with steak and wheat with chicken. All right, so those are 4 possible outcomes. Now the sourdough, what kind of meat could we put on the sourdough breads?
All of them.
All the same exact thing. So here the types we could also have are ham, turkey, steak, and chicken. So the first possible outcome is sourdough with ham. So we're just going to put SD, ham. The next one would be sourdough with turkey, sourdough with steak, and finally sourdough with chicken. So guys, if we look at those different options, how many different sandwich options are there?
8.
You are correct. We came up with 8 sandwich options. Now, of course, you could put tons of different toppings on them, but the main thing, this is what we can do with the bread and with the type of meat. All right, so this is basically a tree diagram. Are there any questions on how to do a tree diagram?
That was kind of fun.
All right, the next set of instructions say to use the fundamental counting principle to find the total number of possible outcomes. So I want you to, with your red pen, write in fundamental counting principle. Here's what the fundamental counting principle is. It says you need to multiply the possible outcomes from each category together to find the total number of possible outcomes. Take your pencil and I want you to circle this word multiply. We're going to do a lot of the fundamental counting principle today, and I just want you to know all you have to do in that case is multiply. So let's look at the options here. Yesterday we did an activity with rolling a number cube. Guys, how many numbers are on the number cube? 6 of them, okay? So it says to find the total number of possible outcomes of, I'd like you to underline this, rolling a number cube and flipping a coin. Okay, so this is a compound event because there's more than one event that we're trying to figure out here. Rolling a number cube. How many options did you guys say are on my cube?
6.
6 of them, so we'll write down a 6. How many different options are there for flipping a coin? 2. There's heads or there's tails. According to the fundamental counting principle, what should I do with the 6 and the 2? Multiply. Guys, what's 6 times 2? 12. So the correct answer is 12 possible outcomes. Now I want you to think back to our sandwich problem that we just did. We spent a lot of time writing out what the different outcomes were. Guys, how many kinds of bread were there?
2.
How many types of meat were there? 4. What's 2 times 4? 8. Is that what we got?
Yes.
So which way was faster, the tree diagram or the fundamental counting principle? So I would suggest from moving on here forward, let's just use the fundamental counting principle where we will multiply the options together instead of writing them all out. Let's go on to the next one. Find the total number of possible outcomes. How many different outfits can you make from this wardrobe closet? So you can see up here at the top, there are some pants. How many pairs of pants do you guys see there? 4. Let's write that down. Next up, there are some different kinds of shirts. Guys, how many different shirts do you see hanging there? There are 7, so we're going to multiply times 7. There's one more thing that needs to go with the outfit. What is it? There's some shoes down at the bottom. How many pairs of shoes are there? 3. Now let's do some mental math. Remember, according to the commutative property, you can switch these numbers around. So let's multiply the 4 and the 3 together. Guys, what's 4 times 3? 12. Then what's 12 times 7?
84.
84. So our correct answer is 84 different outfits. Now, if you couldn't do that with mental math, you of course do have a calculator, but I would like us to use mental math whenever we can. So the correct answer is 84 different outfits. I would like you and your partner to work together to find the answer to problem B. All right, guys, how do we come up with this answer?
5 times 4 times 5.
All right, and when you multiply those together, what do you get?
100 different outfits.
100. Thank you for saying different outfits, because remember, whenever we have modeling real life problems, we want to always make sure that we have units attached. You guys may have a seat. How many of you would say you got that answer, 100 different outfits? All right, very good. All right, find the probability of the compound event. Remember, compound event simply means we're looking for more than one event when rolling a number cube and flipping a coin. So for problem A, it says, what is the probability of rolling a number greater than 4 and flipping tails? Let's just underline those 2 events. Rolling a number greater than 4 and flipping tails. So there's a formula that we want to remember here. Repeat after me. Favorable over total. If you remember, favorable is what we are looking for. Looking at this dice that I have, how many numbers are on here that are greater than 4? 2. What are those numbers? 5 and 6. So I have a 2 out of how many total chances to get that? 2 out of 6. Because it's a compound event, I have to also look at the second event here, flipping tails. What are the odds that I'm going to flip tails, guys?
1.5 chance.
1 out of 2 chances, okay? 1 favorable, there's only 1 tails there, out of a total of 2. According to the fundamental counting principle, what should I do with those 2 fractions? I should multiply them. Now, you can, if you would like, cross-reduce. And if you do cross-reduce, Jocelyn, what do you get? 1/6. Anytime it asks you to find the probability, I am looking for a percentage. Nasir, what would the percentage be for 1/6? Okay, if you do 1 divided by 6, you do get 0.16, and that 6 just continues to repeat. So, as he just said, we want to move that decimal point over, 16.6 many times repeating, but since I asked you to find the nearest whole number, he rounded that, and that is how he got 17%. Now, I did not ask you for the likelihood, but let's just imagine on your quiz coming up on Monday, I say, what's the likelihood of that happening? What would you guys say?
Unlikely.
Unlikely. It's probably not going to happen because it was less than 50%. It could happen, but it's probably not going to. It's unlikely. Let's look at problem B. What is the probability of rolling at most a 4 and flipping heads? Once again, this is a compound event. I would like you to identify, just underline what two things it is that we're looking for. Once again, we're using the same formula, favorable divided by the total number of options. Michaela, rolling at most a 4. How many numbers on here are at the most a 4? 1, 2, 3, and 4. How many numbers was that? 4. 4 out of how many total numbers are on my dice? 6. I have a 4 out of 6 chance of rolling at most a 4. Jace, flipping heads. How many heads are on a coin? 1. And how many sides are on a coin? 2. I have a 1 out of 2 chance, or a 50-50 chance that I'm going to flip heads. Halen, what should I do with those two options? Multiply them together. You can cross-reduce if you want. You don't have to cross-reduce. But if you did cross-reduce, you would get 2/6. Halen, can that be reduced?
It sure can.
To what?
Oh, I guess you should. 1/3.
To 1/3. Okay, 1/3 we know is 0.333 repeating. Okay, I want to move that and turn it into a percent. So now I've got 33.3333333%. Jocelyn, I want that rounded to the nearest whole number. So what's the answer? 33% is correct. Guys, what about the likelihood of that happening?
Unlikely.
That is also unlikely. Probably not going to happen. Okay. This problem is very similar to what we just did, but the difference is now we are spinning what? A spinner, okay? This no longer has to do with our dice. Now we are spinning that little spinner that you can see in your notes. So, two things. We are looking to spin an odd number, so if everyone would underline that. What's the other thing we're trying to do?
Flip tails.
Flip tails. Looking down here on this little spinner, our formula is favorable over total. How many favorable, remember favorable is what we're looking for, odd numbers are there on that spinner? 4. Madison, how many total numbers are here on the spinner? 8. So I have a 4 out of 8 chance of spinning an odd number. Luke, what do I have to do next?
You have to figure out how many possible outcomes there would be for flipping the coin.
Okay, flipping that coin. I'm looking for tails. What do you think is the probability of flipping tails?
1 over 2.
I have a 1 out of 2 chance. Reagan, what should I do with those two fractions?
Multiply them.
Multiply them together. You can cross-reduce them if you want. You do not have to. But if I multiply them across, I would get 2/8. Ellie, can that be reduced to what? 1/4. Guys, what's the decimal for 1/4?
0.25.
0.25. So what would that be as a percentage? 25%. What do you think? Do you think it's going to happen?
No. It's unlikely.
It is unlikely that that would happen either. Problem B. What is the probability of, we have a compound event again, we want to spin a number less than 4, and we want to flip heads. Just the girls, how many numbers do you see on here that are less than 4? 3 out of?
8.
3 out of 8.
I told you.
Boys, flipping heads, what are the odds? What's the probability?
1/2.
1/2. There's a 1 out of 2 chance, 50-50 chance. When I multiply that out, girls, what's the answer?
3 over 16.
3 over 16. 3 divided by 16 equals 0.1875. Abigail, how do I turn that into a percent?
You have to move this one 2 times, and then the tens place has to ask the hundredths place if it's bigger than a 5, and it is, so it's 19%.
So it is 19%. Okay, once again, it is unlikely. It looks like most of our compound events, or all of our compound events, in fact, are unlikely and probably not going to happen. when we had homework over 7.2, there were a few people who were confused about how to do it. So I want to do a couple review problems with you today because your first couple problems on tonight's homework look just like this. Use the bar graph to find the experimental probability of the event. Guys, what is the formula for experimental probability? Everyone say that together. Successes over trials. So we take how many times we successfully got something and divide it by the total number of trials or times that we tried it out. Halen, how many times, if you look at this right here, did we successfully roll a 5? 19 times. Let's just look at this down here. Make sure we understand. Guys, which number did they roll the least?
1.
The number 1. Look, they only rolled it 13 times. Which number there did they roll the most?
6.
The number 6. It looks like they rolled it 20 times. So now, my original problem never told me how many times they did this. Can someone explain to me how I can figure out how many times did they roll this number cube? Abigail.
Just add all the answers here.
Good job. We're going to add 13 plus 16 plus 15 plus 17 plus 19 plus 20. So I want you guys to do that now, and that's going to help us know how many trials there were. All right, guys, when you added that together, what'd you get? 100. So let's just talk. Remember, probability, we always want to turn it into a percent. Guys, 19 out of 100, what percent would that be? That is 19%. Okay, so we've got one final problem we're going to do where it asks us about rolling a 1 or a 2. Remember, once again, we are trying to find out how many times we successfully got a 1 or a 2 and divide it by the total number of trials that we had. How can I figure out how many times they successfully got a 1 or a 2? Nasir. I add them together. You can see they got a 1 13 times. They got a 2 16 times. Ellie, how many times did they get a 1 or a 2 successfully? Michaela, how many times? 29, okay? 29 out of, Reagan, how many total times did we say that they did this?
29.
They got a 1 or a 2 29 times, but how many total trials? Out of 100. Guys, 29 out of 100, what percent is that? 29%. Okay, so as I said, the first couple homework problems you have tonight are going to look just like this. If you have not yet, please label for tonight's homework. It is 7.3 and there are only 8 problems.